All right, so we're going to look at 4-2 part A, which is just polynomial functions, okay? So when you guys work with polynomial functions, remember polynomial functions are just items or functions, I should say, not items, but equations with exponents, okay? So this is a polynomial function. Y equals x squared plus 3x plus 4. That's a polynomial. This is a polynomial. Y equals 9x to the 5th minus 7x to the 4th plus 6x squared minus 10. Okay, that's a polynomial. Those are polynomials. Just examples. Okay, you already worked with a polynomial. This is a special type of polynomial. That's a quadratic. So x squareds are a quadratic polynomial. This is an x to the 5th polynomial. So when we talk about these things of a polynomial just means you have a whole bunch of terms. And what are terms? Terms are separated by addition or subtraction. So these are all terms right here. So anywhere you see between the plus or minus sign, those are terms. Things we've talked about before, these are terms. Just like when you factored quadratics, trinomials, all of those kind of things. Those are just the terms. Okay? So when we look at polynomials, the number that's in front of the leading term is called the leading coefficient. All right? So it says the coefficients, all of this stuff. This is why kids get confused with math, because they see all of this garbage right here. Okay? And it lists what a of n is. Look where a of n is at on the actual function. A of n is called the leading coefficient. And coefficient just means the number out front. So when we talk about a leading coefficient, it just means what's the number out front. So when I look at this example in this set where it just says, hey, what's the degree and what's the leading coefficient? Degree is just the largest exponent of the problem. So this right here, if you go through the functions and look at the largest exponent, that's the degree of the problem. So this is a 5th degree polynomial because the largest exponent is 5. It's not the largest number. I see a 9 there, but it's the largest exponent. 5, 4, 3, 2, he doesn't have any, so his degree is 5. Largest exponent, this guy's degree is 4. Largest exponent, this guy's degree is 3. Largest exponent, this guy's degree is 2. Hey, do I see an exponent here? No, but it's there. So if you see a variable but it's missing an exponent, it's an exponent of 1. So if you notice, we've given you an example of a 5, a 4, a 3, a 2, a 1, 1st degree polynomial down to a 5th degree polynomial. So just knowing that, you know the degree on this one has to be 0. Now how can you tell that by looking at this guy? This guy has no variables. No variable. If you have no variable, its degree is 0. Because no variables means I have 0 variables for it to have a degree. So this is just what's called a constant function, which a constant function is a flat line, which a degree of 0, the degree tells you what it does. A degree of 0 means this graph doesn't do anything because it's just a flat line. Okay? It's just staying still the whole time. It's just flat. There's nothing exciting about that. If you were on this roller coaster, you would be bored out of your mind. You're like, why did I pay money to go on a flat line? I could have just drove here. Okay? So a degree of 0 has no variables. Now over here where it says leading coefficient is just the number in front of the leading term. This is the leading term, 9x to the 5th. So what is the leading coefficient? The leading coefficient is just the number out front, so the leading coefficient on this is 9. This is the leading term. What's the leading coefficient? -3. This is the leading term. What's the leading coefficient? Ooh, there's no number there, but there is a number, so it's -1. So it's just the number out front. Okay, leading coefficient is the number out front, and degree is just the largest exponent. Don't make that harder than what it is. Okay, don't make that harder than what it is. Remember, if you need anything, if this is like any of this, you get lost, come back in, chat with me. Okay, math videos are so super exciting, I know sometimes. So if any of that, if you don't get it, just log back in and talk to me. Okay, these are graphs. Okay, so polynomial parent functions. What is a parent function? A parent function is the original function. Okay, it hasn't been mutated by other numbers or anything like that. So it's just a very basic function. The most basic function with no numbers to shift it, no transformations, no nothing, just the very basics. So a quadratic function, what's the very basic quadratic function? Y equals x squared. A quadratic function has a degree of 2. We spent a whole unit graphing these. So you know it's a U-shape. You know its degree. A quadratic function is a degree of 2, which what does that mean? It has an exponent of 2. So for example, what could a quadratic look like? It looks like this. Could it be flipped over? Yep. Kids, when it has a degree of 2, that means the roller coaster does two things. It has a part where it would go downhill, and it has a part where it would go uphill. So do you notice the change? So the degree of 2 tells you the stuff that it's doing. It's doing two things. It's got a downhill and an uphill. This roller coaster has two parts. So if you look at a graph of a cubic function, a cubic is a big fancy pants word for y equals degree of 3, which is an exponent of 3. So that means it'll have 3 portions of a graph. A U-shape has 2 sides. When you learned how to write a U-shape, you had 2 sides. You went down and then came back up. So a cubic, same idea, could look like this. It could go up, it could turn around, and it could go back up. It could have 3 parts to it. Okay, now how high or low the graph goes, it has an up part, it has a down part, and it has a part where you go back up. So if you ride this roller coaster, which roller coaster for you is more exciting, the quadratic or the cubic? The cubic's more exciting. You get more for your money. You get 3 parts for your money. Quadratic, not as exciting. You got a down part and an up part. Cubic, up, down, up. Or it can be the other way, but it's doing 3 things. See my 3 old man fingers there? It's doing 3 things. We haven't graphed cubics yet. You will a lot over the next couple weeks. A linear function, you know a linear function is a line. What's the very basic parent function of a linear function? Y equals x. It is a degree of 1, which means it does one thing. It doesn't change. It doesn't go back up and down. It just does one thing. When you guys graphed lines, you did this. Look, it's just doing one thing. It's just going up, it's going up, it's going... It might just go down, but it doesn't change like a quadratic does. Okay? And a constant is just y equals some number. There are no variables on a constant. So it has a degree, just like what we talked about, has a degree of 0. So it's very boring because a constant function is just a flat line. When I say flat, I should say horizontal. So if any math people watch this, they'll be like, Dasha, that's a horizontal line. I know. Okay, so what does a constant function look like? It looks like the worst roller coaster in the world because it doesn't do anything. It stays flat. The larger the degree, the more it does. So if you have sides to it, so if I flip this over, or if I go to the next page, mine's blank on the back. If you flip yours over in the notebook, on the top, you'll see that it talks about a quartic and a quintic. Well, those are the same types of ideas. A quartic is an x to the 4th. Remember, the root word of quartic is quart. Quarts means 4. 4 quarters in a dollar, 4 quarters in a school year, 4 quarts in a gallon. So quartic means 4, so this would be a degree of 4. So what's that going to do? It's going to do 4 things. So make your roller coaster do 4 things. 1, 2, 3, 4. There it is. It could look like that. Could it be flipped over? Yes, it could be flipped over. Okay, but there's a quartic. It does 4 things. Okay, it's got a part where it goes down, It's got a part where the roller coaster climbs back up to the top of the mountain. That's awesome. It got a part where it slides back down. It's got a part where it goes back up. Do you notice how it does 4 things? Which roller coaster is better, a quartic or a cubic? A quartic, you get more for your money. You get 4 parts. So you're pretty good with patterns. Great. If that's what a quartic looks like, then, hey, let's talk about a quintic. After that, I really don't name it. I just call them polynomials after that. Polynomials has exponents. Now, understand, it may have more things behind it. It may say like plus 5x to the third, minus 16x, plus 2, whatever. But the leading term, x to the 5th, which has a degree of 5, the leading term determines what this thing does. It's x to the 5th, so it goes 1, 2, 3, 4, 5. There we go. There we go. Does 5 things. It's got 5 pieces of the roller coaster. Up, down, whatever you want to say. Down, up, down, up, down. It does 5 things. Okay? 5 things. 5. All right, now let's talk about this. These were the things I started the video with. So instantly, you may see all of this other stuff going on with the polynomial. Kids, I don't care about the other stuff. This has the most influence over the graph. The x squared on this guy, this quadratic function, has the most influence. On this graph, this guy's got the most influence because he's got the largest exponent. Exponents are like muscles, okay? So they direct traffic. So this 9x to the 5th, no matter what this other stuff does, it has some effect on the graph. But it's still determined, the shape is still determined by this guy. So he's still going to be 1, 2, 3, 4, 5. He's going to look somehow, some way. The bumps might be higher, they might be lower. It's still going to look like this. Okay, we can get it more detailed as we graph that stuff. But somehow it's going to look some version of that. A quadratic function. This stuff matters. I'm not saying it doesn't matter. It does matter, but I know instantly, since it's an x squared problem, bang. These things don't change the shape of the graph. They change the location, but not the shape. Okay? So they might dictate like, hey, this is moved to the left or up a little bit more, but it's not going to change the shape of it. The leading term, the term with the largest exponent, has the most influence over the graph.